All right, so let's talk about electrolytes. So you might have heard of the term electrolytes if you've, watched a sports show or drank some Gatorade or Powerade or anything like that. You may have heard electrolytes in that terminology. So let's talk about what an electrolyte is. So an electrolyte is a material that dissolves in water to form a solution that will conduct electricity. Okay? So an electrolyte is a solution that dissolves in water to form a solution, a material that dissolves in water to form a solution that will conduct electricity. A non-electrolyte is kind of the opposite. This is a material that dissolves, it still dissolves. It's still going to dissolve in water, but it's going to form a solution that will not conduct electricity. So the difference between these two, they both dissolve, but one conducts electricity, one doesn't. So here's an example. So I have kind of a electricity kind of setup here, conductivity setup. So I've got a light bulb, I've got a battery, and I've got two different magnetic poles here. So just stick it in, and then if I put and make a solution, so here's a salt solution, and so I'll tell you in the next slide why salt is conductive, why it's an electrolyte. But if salt is an electrolyte, it's going to conduct electricity. So in a salt solution, it actually conducts electricity and lights up the light bulb. This is one of the reasons they always kind of tell you, like, don't go swimming in a lightning storm, because it conducts electricity if it's salty enough. Whereas sugar, if I drop in the sugar, sugar dissolves. So we know sugar dissolves in water because that's how we make our sweet tea and all those kind of things and our sweet coffees. But it does not conduct electricity. My light bulb doesn't light up. So how can I predict which ones will be electrolytes and which ones won't? So we're going to talk about some characteristics of looking at a molecule and being able to figure out if it's going to dissolve and if it's going to conduct electricity or not conduct electricity. So let's see. So remember, we kind of talked about this before. In order to conduct electricity, you have to have two things to conduct electricity: charges and be able to flow. So you have to be able to have charged particles and be able to flow. The flow part really isn't an issue in this chapter because everything is a solution, right? So everything's either a liquid by itself with something dumped into it, or it's going to be dissolved in water. So everything's solutions. So everything can flow in this chapter, so we don't have that issue. The issue we have are these charged particles. So to conduct electricity, I have to have charged particles. So electrolytes have to have the charged particles. Non-electrolytes end up not having them. That's why they don't conduct electricity. So my electrolyte solutions, they're going to have charged particles, and these will not. So electrolyte solutions all contain ions dissolved in water, where non-electrolyte solutions contain whole molecules dissolved in water. So let's think about the different type of molecules we've learned about so far. So one of the ones that we talked about when we learned our naming was ionic. So ionic compounds, and let's look at our salt. We go back, this was salt, right? An ionic compound has ions, right? It has positive and negative ions. That's what makes an ionic bond, is that attraction. So they already have charged particles. So if it is an ionic compound, it's going to be an electrolyte solution. So electrolytes are ionic compounds, or ionic compounds are electrolytes, sorry. Whereas the other type we talked about are covalent, are molecular compounds. Those are going to be non-electrolytes. So molecular compounds are non-electrolytes except for acids. And we're going to talk about acids and bases in this chapter later on. Okay? So, ionic compounds are electrolytes. Molecular compounds are non-electrolytes. So let's look at that on the next slide. So salt, we know, is NaCl. So it's a metal and a non-metal, a cation and an anion. So we know it's an ionic compound. When I dissolve it in, I have ions. So it's going to break apart into the ions. So this is why it conducts electricity, because you have charged particles and it could flow because it's dissolved. Molecular compounds like sugar, here's my molecular compound. It can dissolve, but it doesn't break apart. There's no ions. It just stays as these big clunky compounds of C's, H's, and O's. So remember, molecular compounds are all nonmetals. So sugar's got CH's and O's, glucose, fructose, sucrose, all those oses, okay? So they just have carbons and hydrogens and oxygens, and that's it. And so they're going to dissolve, but since there's no charges, it can't conduct electricity, okay? So you have to be able to have ions, and you have to be able to dissolve to be an electrolyte. So I said that one of the exceptions were acids. So on the next lecture, we're going to talk a little bit about an acid.